Welcome everyone. Today in this section we are going to do GCSE physics mock hard questions. Basically, these are mock questions and they are comparatively harder questions. If you know the basics for harder questions, definitely the basics are important for you to know. If you are done with the basics, then you can definitely go for these questions. Even if you're not aware, you can just do it with me. Before I start, I want to just clear it that I have started the GCSE batches one on one, or you have batches and one on one both. You can enroll yourself, and if you want to, you just have to email us at exactacademy@gmail.com. So, just let me start with this question. It says this is a circuit, and there is a power supply here, and there are four resistors, and the value of each resistor is given. We have to calculate the voltage across R1 if current across R2 is 3 amp. Current across R2 is 3 amp. We know the resistance across R2 plus we know the current across R2. So V is equals to Ri. Two things I know, that means I can calculate the third one, which is voltage. So I can calculate the voltage across resistance 2. So it's R2 times I2. Resistance 2 is 4 and I2 is 3 amps. So into 3, answer is 12 volts. Now we know that the voltage across R2 is 4. We know that if anything is connected, like whether it's a lamp or resistor, if they are connected in parallel, they share the equal value. That means whatever be the potential difference across the whole circuit, the same voltage drop will be there across each circuit. That means if we have calculated 12 volts across this, then 12 volts will be across this as well, and 12 volts across these two together, right? Definitely, because they both are in series, so voltage gets shared. So in this case, I can't say that R3 and R4 both have 12 volts, but the ones that are connected in parallel have the same voltage. So definitely, if this has 12 volt, this will have the same voltage. So what will be the voltage across R1? It's gonna be 12 volts. Next, calculate the total power given by the power supply. Power given, whenever it's power, it's V times I. We just calculated the total potential difference, which is this, because if this is 12 volts, this is also 12 volts, this whole 12 volts, and this power supply is also giving 12 volts, because they all are connected in parallel. And this is the reason whenever we calculate the potential difference and we have to connect the voltmeter, we always connect in a parallel circuit, because the total is equals to across each resistor. So P is equals to VI. We know V is 12, but unfortunately we have no idea of I, because in parallel current is shared. We only know the current across R2. We have no idea for R1 and R4, R3, no at all. So for that we have to go for the other one, that is resistance. Definitely, if they are asking the total power, that means its power total is potential difference total into current total. Because we don't know the current, I can apply Ohm's law, which is V is equals to Ri. From here, I can say, I can replace I, because there is no I, so I need to replace it. From here, I can say I is equals to V over R. If I is equals to V over R, in place of I can write V over R. So power is now V squared over R, because we have only the knowledge of potential difference and resistance. So this formula is going to help us. So voltage drop here is, we just calculated as 12. So 12 whole squared over R total. We know what is R total. We just need to calculate it. The values are given. R1 is 2 ohms. R2 is 4 ohms. R3 is 6 ohm. R4 is 4 ohm. I'll first start with the series one. These two are in series, so let me add them up. So 6 plus 4 will give us 10. So now if I simplify this circuit, it turns out to be like this is 2 ohm, This is 4 ohm, and these two together I have added them, and now this is equivalent to one big resistor which is of 10 ohms, and this is a power supply. If they all are in parallel, we know that to calculate the total resistance in a parallel circuit, I need to add their reciprocals. So 1 over R total is equals to 1 over 2 plus 1 over 4 plus 1 over 10. LCM is 20. This will be 10 plus 5 plus 2. That is 17 over 20 is 1 over R total, right? So this is 17 over 20 is not R total, it is 1 over R total. So to calculate R total, I need to reciprocal it. So R total is going to be 20 over 17. So if R total is 20 over 17, so I can say this one be 12 squared is 144. So 144 over R total is 20 over 17, or 144 into 17 over 20. This can be simplified as 122.4 watts. This is your final answer. Moving on to the next one. There are two light bulbs. One is marked 120 volts and 80 watts. Another is marked 120 volts and 40 watts. So this is basically their reading. The 80-watt bulb has dash resistance. We have to calculate as compared to the 40 watts bulb, which one has more or less resistance. We know the voltage and the power. We just saw power is equals to V squared over R. So if you want to calculate R, this will be V squared over P. I have just rearranged it. For the first bulb, I can say that the resistance of first bulb is voltage is 120. So 120 squared divided by 80. This will give me answer as 180. And resistance for R2, same, using the same formula, that means 120 into 120 over 40 is 360. Even without calculating, just by looking, we can see that resistance is inversely proportional to the power. So which one has a higher power will have a lower resistance, and lower power will have a higher resistance. So obviously 180, that is R1, or you can say first light bulb, has a lower resistance as compared to the second one. So the 80-watt bulb has just so less resistance. Now, and therefore glows which bulb? The bulb which has higher power glows more. Which one has a higher power? Definitely 80-watt has a higher power, so it glows more brightly. If these two bulbs are connected in parallel, then we obtain more current or voltage compared to when they are connected them in series. Now let me see. We have just calculated the resistance. So this is lamp 1 and this is lamp 2. Let me see. Say for example, we have connected it into parallel circuit. When I connect into parallel circuit, the total resistance will be 1 over 80 plus 1 over 360, because we just saw that the resistance of this first one is 180, second one is 360. So this will be 3 over 360 or 1 over 120. Reciprocaling it, I'll get 120 as my answer. So total resistance in this case is 120. And if total resistance is 120, so now let me connect into series one. When you connect into series, total resistance will be 180 plus 360. We just need to add them up. This will be 540. Because they are connected with the same battery, so we can assume that the potential difference is same. In that case, we know that current is inversely proportional to the resistance. So whichever the connection will have the lower resistance will have the higher current, obviously. So in this case, when they are connected in parallel, we obtain definitely more current as compared to when we connect them in series. plus their rating, if we compare them, are on the same, so definitely we are assuming the potential difference be same in that case. Now calculate the reading of voltmeter. This is question 1.3 and it says we have to calculate the reading of voltmeter. Here you can clearly see current is flowing in this circuit, and when it flows, obviously it will cover this one. There's no chance that the current will flow here, because this current will pass through this and complete the circuit in this itself. So what will happen? Why? Because here also there is no resistance, least resistance, there is least resistance. So what will happen? That complete current will pass through this one itself. So rather than passing through this one, it will cover the circuit like this. So no current will flow here, and we can say, and if there is no current, that means there will be no voltage. So calculate the reading of voltmeter here is going to be 0. No potential difference there, no current there, it's 0. Calculate the charge passing through 2 ohm resistor in is 2 minutes. Okay, so we know what is current. Current is equals to Q over T. That means current is charge over time. So what is given? 2 ohm resistor is 2 minutes. 2 ohm resistor, here we have to calculate the current across the 2 ohm resistor. We know that if circuit or if the lamps or resistors are connected in series, they share the same current which is there in total current given by the battery. Total resistance here is 4 plus 2, 6. So when I apply V is equals to Ri, I get voltage is 6 and total resistance is 6 as well. So total current turns out to be 1 amps. That means same 1 amp current is flowing through 2 ohm resistor and same 1 amp of current is flowing through 4 ohm resistor. What it says, calculate the charge passing through 2 ohm resistor. Current is 1, charge is Q, and time is 2 minutes, but we need to convert into seconds. So 2 into 60, 120. So charge will be 120 coulombs. That's your final answer. It says state one difference and one similarity between convex and concave lens. See, concave lens looks like this, a cave shaped. So this is a concave lens, whereas this is a convex lens. Similarity is they both refract the light. So what is similarity? I can write is that they both refract the light. Important is they are not reflecting. The lenses always refract the light. The refraction, that means when a light moves from one medium to another medium. Medium is in which it's traveling. A liquid can be a medium, a solid can be a medium, a gas can be a medium. So if it travels from one medium to another, that means if two different mediums have different densities, not necessarily that liquid to solid or solid to gas, even it can move from liquid to liquid, it all depends on its density, more specifically its optical density, but yeah, its density. That means what happens is when a light travels from one medium to another medium, suppose this medium is less denser, so definitely the particles are a little bit away from each other. If this is more denser, the particles are tightly packed with each other. Clearly, if you are moving in a very crowded place, or if you are moving in a very like there is no crowd, so obviously you can run where there is no crowd. Similarly, it's for light. A light can move faster in a less dense medium where the particles are less dense, the number of particles are lesser over a unit volume, whereas if a light moves in a more denser medium, it travels slower. And this happens, suppose here it's traveling, it travels quite faster. When it enters here, it start to travel or start to move slower. And this results in bending of light. This bending of light is called refraction. So same thing happens here, because obviously when light travels from one medium and this lens is a different medium, so it basically refracts light. So I can simply say they both refract the light. Now the difference is how they are exactly refracting the light. That tells us the difference. When a light enters in a concave lens, this is a concave and this one is a convex. This concave is also called diverging lens, whereas this convex is also called converging lens, and from here the difference arise. Definitely they are refracting, but this mirror or this lens is refracting the light and moving it away from each other. That means concave actually diverges the light. This lens diverges the light. Whereas if I talk about the convex lens, because it's also called as converging lens, I can say that it converges the light. So when light enters, light converges at one point, so that means they are coming closer. Whereas in diverging lens or concave lens, it basically diverges the light. So here I can say that concave lens diverges the light, whereas convex, this lens converges the light. Moving on to the next question. This is also related with the lenses. Draw a labeled ray diagram of convex lens and show that the convex lens forms the image of object when the focal length is 20 centimeters and the object is placed 30 centimeter from the lens. Whenever we draw a ray diagram, we first have to label it. This is my principal axis. This is the imaginary line which passes through the optical center of the lens. Optical center of the lens is the center of the lens. When I draw a ray diagram, we never draw the lens, we just represents the lens with a straight line. If it's a converging lens, this will be the sign or symbol, whereas if it's a diverging lens, this is the symbol. Here they have told us convex lens. So obviously what we need to do, we just need to make this symbol. That means this complete represents a convex lens. Second is we have to place the focal length or the principal focus. Principal focus is a point where all the light converges or either they are meeting or appears to meet, and that happens in a case when it's a diverging light. So here they have mentioned that the focal length is 20 centimeters. Focal length, that means that then the length between the principal focus and the optical center. This is the optical center. This O, let I name it O. This is your optical center, center of the lens. Distance between the focus and the optical center is your focal length, and this distance is 20 centimeters. Obviously you can't draw 20 centimeters in your copy, and then you have to draw the 2f, which is a 40 centimeters. So let me take a scale which is much better. I can say that either you can take 5 centimeters is equals to 1 centimeter, or 10 centimeter equals 1 centimeter. I would suggest for a proper diagram it would be better if you take 5 centimeter equals 1 centimeter. That means here we have to draw 4 centimeters. This is f. So with the same distance you have to draw f here as well, because the lens has two foci on either side of it. So both should be 4 centimeters away from the lens. 2f is at twice the distance, because if this distance is 20 centimeters, though in our copy it is 4 centimeters, but you have to draw it that this is 20 centimeters. So this is going to be double of it, that is 40 centimeter. But while drawing it's going to be 8 centimeter. This is the scaling, that I don't get confused. Scaling is different from the actual length. Scaling we have taken 5 centimeter equals 1 centimeter. So 20 centimeter can be represented with 4 centimeter and 2f would be 8 centimeters. But here labeling will be for the real values. This is 2f, and similarly on this side also I will write 2f. What it says, an object is placed. They haven't mentioned height of object, so it's totally on us which length we want to take. The object is placed 30 centimeter from the lens. 30 centimeter, clearly that means it's between 2f and f and just at the mid of it. So I'm drawing the object which is here. This is my object. Next is, because it's a converging lens, we have to draw 3 rays, but I would always suggest to go for 2 rays And what two rays? Only these two rays for any, wherever is the location of the object, always draw these two lines and you'll get a perfect answer. First is, let me draw a ray which is parallel to the principal axis, and once it touches the lens passes through the principal focus. This is your first line. And second line would be the line that passes through the optical center and goes undeviated like this. Wherever these two meet will give you the final answer, which is this. And definitely when the object is between f and 2f in case of convex lens, the image formed is always real, inverted and beyond 2f, and you can clearly see here it's beyond 2f. We have to show the arrows as well, that's moving like this. Now this is our complete ray diagram. Calculate the magnification produced. Use the physics equation sheet C. See, the magnification is the ratio of height of the object and height of the image. We have to see how much an image has been magnified as compared to the length of the object. Height of image over height of object. Now, problem here is because I haven't measured it properly. That means it's 20 centimeters, right? So the ratio, I don't know, I haven't taken it accordingly. It was just to tell you that how exactly we can do. But whatever be the height of image, you have to measure it with the ruler. This will be the height of the image, 12 centimeter, 2 centimeter, 3 centimeter, whatever it comes out to be, divided by height of this object. This will give you the magnification. A convex lens forms a virtual image when the object is placed between C. Convex lens produces always the inverted and real image. Only the case where it produces the virtual image is when it is placed between the center, that is your optical center, and the principal focus. That means here, if this is principal focus, this is optical center. If you place object anywhere in between that, you will always end up getting a virtual image. So a convex lens forms a virtual image when it's placed between principal focus and optical center. Or if you don't want to write optical center, you can simply write between lens, would be more appropriate. 2.3, complete the following diagram. See, this is a glass slab given, a light is coming. Definitely what kind of phenomena occurs? It's a refraction because light is traveling from one medium to another medium. So we need to complete. First is we have to draw the imaginary line which is called the normal. That is a perpendicular line to the glass slab here. This one. This light enters, I can say this is I because it's an incident ray. Then what happens is when it enters from one medium to another medium, this is a less dense medium because we're assuming this is moving in air. So less dense medium to more dense medium, that means its light of a speed will decrease and the ray of light will bend towards the normal. So after the reflection, this will bend towards the normal like this. This is your definitely a refracted ray. This angle which it makes with the normal is called angle of incidence, and that it makes with the refracted rays angle of refraction. Now again the refraction will occur because now it's leaving the glass slab and again moving to a different medium. So we have to draw a normal. And again the refraction will occur. So I can say that it will now move away because the speed of light will increase basically. So it will move away. So this is called your emergent ray as well. So I name it as I am representing emergent ray. Here also I can say this is angle of incidence in this case, and this is angle of refraction. It says explain what is critical angle. See, critical angle is angle in phenomena of refraction. They are asking in terms of refraction. So suppose this is a slab or this is a particular medium. When light enters, specifically when light enters from denser medium to less dense medium, this is important. That means when light is entering from this to this, then only this phenomena will occur. So say for example, these are two different medium. Let's say this is more dense medium and this is less dense medium. When light enters, what happens in less dense medium? It bends away from the normal, because I told you when it moves to the less dense medium, the speed of light increases, so it bends away from the normal. So it bends away from the normal. If you suppose this angle of incidence be 30 degrees, definitely in this case always this angle is going to be greater than angle of incidence. So it can be 40 degree, 50 degree, depending upon the glass slab or the material. Suppose you have increased the angle of incidence. If you have increased the angle of incidence, definitely the angle of refraction will also increase. So it will like this. That means it will move away more than from the normal. Then you have increased more than it. Then maybe the situation arises that this moves so much away from the normal that now the angle is 90 degrees. Definitely if you are making 30, it becomes 40. If you are increasing, it goes to 50, 60, 70, 80. So 90 is definitely possible. So the point at which, or the angle of incidence at which the angle of refraction is 90 degrees, that is your critical angle. So this angle is critical angle. If you furthermore increases the angle, now you have increased the angle furthermore like this. So obviously it will move more away from the normal. So greater than 90 degrees. So it will be like this. So what's happening here? It's very easy to understand that if you have increased it more, this is angle of incidence. Now this was angle of refraction. If you have increased more, the angle, this ray will be in the same medium, right? It was our initial medium, that is more dense medium. It will come back to its initial medium, and now it's no more a refraction, because the definition of reflection, I'm talking about reflection, is when light bounces back in the same medium and it appears exactly that the reflection is happening, and this phenomena is called total internal reflection. Now basic reflection is different and the total internal reflection is different, because in total internal reflection what's happening, that previously the refraction was happening, but when you keep on increasing the angle of incidence and when you increased it more than the critical angle, then no more refraction can occur. Instead reflection occurs in this case, and this kind of reflection is called total internal reflection. So according to the definition that I explained, I can say that the angle of incidence for which angle of refraction is 90 degrees is called critical angle. So I can say optional, you can draw a very little diagram, a very small diagram, to show that this is the angle of incidence and for which angle of refraction is 90 degrees. So this is theta r is 90 degrees, theta I is actually theta c, that is with this critical angle. Second be total internal reflection. If the angle of incidence increases more than the angle of refraction or more than the critical angle, so you can say TIR, I'm just writing TIR, total internal reflection. If angle of incidence increases beyond the critical angle, so no more refraction takes place. Instead, the light bounced back in same medium which is called total internal reflection. Now part 3 says complete the following sentences. A ray of light, when it enters from one medium to another medium, we just studied what happens. It refracts. A ray of light refracts, or you can say bends. Either you can write refracts or you can say bends. When it enters from one medium to another medium. When a ray of light is incident normally on a rectangular glass slab, it travels through the glass slab. See, it says this is your glass slab. We know this is a normal, which is an imaginary perpendicular line. Suppose a light ray falls on it. What will happen in this case? So when a ray of light is incident normally, completely, it's making 90 degrees to the glass slab, it travels through the slab undeviated. No bending will occur in this case. How can it bend? It goes like again, it will make 90 degrees. So you can simply say through the glass slab undeviated. The incident ray is always dashed to the emergent ray. Okay, this we have drawn it. Now you can see. And here one more thing we have to add, as I told you, whether it's a critical angle or it's TIR, we have to write when a ray of light travels from more dense medium to less dense medium. And same in the case of TIR also, you have to mention that when a ray of light travels from more dense medium to less dense medium. It's a little messy here. This is incident ray that enters, and this is emergent ray that is leaving the slab. And what is the relation between them? If I exceed this one, see this one, they both are parallel to each other. If you exceed this one as well, you can clearly see these two rays are parallel to each other always. Whenever you draw any ray, it will give you a better idea that whether your diagram is correct or not. You have to check that the incident ray, is it parallel to emergent ray or not. So the incident ray is always parallel to the emergent ray. Now question number 3. Wooden block of 1 kg and dimensions 30 times 20 times 10. That means always the dimensions, if they are written in terms of times, that means the first represents the length, second represents the width, and third represents the height. Is floating on sea. What happens when 6 such blocks are connected lengthwise? Will this block still float in water? If yes, then why? And if not, then why? See, clearly that it is, if you increase, if it's the same material, the density remains the same. That's the simplest logic. So even if you increase, if you double the size, triple the size, or 4 times the size, doesn't matter, the density will still remains the same. So if previously even the small chunk of that particular material is floating, then definitely even a bigger block of the same material will also float, because still it has a lesser density than the water. Now this we have to prove. Either you can say that, because we know density is equals to mass over volume. So density is directly proportional to mass and inversely proportional to volume. If the mass of the object increases, at the same time the volume is also increasing. So what's happening? When mass increases, density increases, but volume is also increasing. If volume increases, density decreases. So what is happening? Density is at one point is increasing, at decreasing. So the both are compensating, and which makes the density as it is. And this is the reason, even if the volume increases, the mass is also increasing, and it will remain exactly the same. So here we have to prove by this one that density of block is, mass is 1 kg and volume is 30 times 20 times 10. That means 30 times 20 times 10. This is going to be our density. Let me convert it into meters. So I can say 10 to the power of minus 6, or it will be 10 to the power of 6 over 6,000, or 1000 over 6. This is our density. Now if six such blocks are there, so what will happen? The mass will be 6 times now, 1 into 6, and volume will also become 6. So 6 times 30 into 20 into 10 into 10 to the power of minus 6. So you can see, if the mass is increasing by such a scalar quantity, the volume is also increasing by the same scalar quantity, and ultimately answer comes out to be 1000 over 6. So density is still the same. So will it float in water? Previously it was floating on water, as density is same, and density is a property that depends on the material, and density depends on material, yes, it will float. Here I can say kg per meter cubed. The same block is trimmed to a cylinder with a radius 5 cm, height 21 centimeters. Then calculate the mass of the cylinder. What is the density we have calculated? 1000 over 6. So density is equals to mass over volume. Density is 1000 over 6. Mass we have to calculate. And what is the volume of cylinder? Volume of cylinder, don't get confused while substituting the values in the formula. It's just a simple formula that I'm using. Density is equals to mass over volume. In place of density, I wrote 1000 over 6 that we have already calculated. As I told you, doesn't matter whether it's in a shape of cone or a cylinder, the value of density remains same, as it's the property which depends on the material. So 1000 over 6, mass we have to calculate. In place of volume, I'll write the volume of cylinder. Volume of cylinder is pi r squared h. Pi r squared h. Pi is 22 over 7. R squared is 5 squared, which is 25. And height is 21. From here, this will be 3. That is 22 into 75. I'm not simplifying it as of now. I'm just directly putting it here. 22 into 75. From here, I can say mass is equals to 1000 into 22 into 75 over 6, which is, and definitely because it's in centimeters, so I need to convert into meter cube, 10 to the power of minus 6. Final answer is 0.275 kg. This is the mass of the block, which is in the shape of the cylinder. 3.2. This block is placed vertically on the floor. Calculate the pressure applied by this block on the floor. See, we know pressure is equals to force over area. Now force, if it's placed on its own, that means force is what? Its weight. Weight is what? Mg. So pressure is now mg, because it's downward direction. Your force applied is, if not there is an external force, it's body weight. Over area. Area is because it's placed vertically. So the area of the shape that is in contact with the floor is this part, which is pi r squared. That is the cylindrical one. So pi r squared. Area is pi r squared. M we just calculated as 2.75. So this will be 0.275. Since they haven't mentioned which you are taking, so we can take GS10 for simplification of our calculation. You can take it 9.81 more specifically, that is much good. If you are taking 9.8 or 9.81, let me take 9.8. So multiplied by 9.8 divided by pi r we just saw was 5, so 25. Final answer will be, and also because it was in centimeter, so into 10 to the power of minus 4. Area, if you convert centimeter squared into meter squared, multiplied by 20 to the power of minus 4. Final answer is 343.138. So up to 2 decimal place, 343.14 Newton per meter squared. Now, or you can write pascals directly. This block is roll down on the floor with a velocity of 20 meters per second, how much time will it take to stop the cylinder if a constant frictional force of 5.5 Newton is being exerted on it? Now what's given? They have given the velocity. Roll down on floor, that is initial velocity is 20 meters per second, and they want it to be stopped. That means final velocity is going to be 0. Force applied is 5.5 newtons, and you have to calculate the time. So I'm just applying F is equals to mass times acceleration. Mass we just calculated, we have the value of mass, it was 0.275. So 0.275. Acceleration is change in velocity over time. 5.5 change in velocity, that means v minus u over t. So 5.5 is equals to 0.275. Final velocity is 0 and initial velocity is minus 20 over t. Let's not take sign here because we want to calculate the time, and time is a scalar quantity. And also frictional force is negative, so negative 5.5 here, and negative velocity cancels out and making it positive, and time is 0.275 into 20 over 5.5. This is equals to 1 second. That means it will take 1 second for this whole body to come to the rest. So that's it all for today. These questions are available on ESAEY app. Link is in the description box. And again, if you want to enroll yourself for one-on-one classes or for the group classes, just email us at exacademy@gmail.com. So that's it for today. Thank you and have a great day. Bye.